Whitney, do you want to just kick off for us?
Hi, everyone. Thank you so much for joining us today. Just a couple of housekeeping items. If you have any questions, feel free to add those in the meeting chat function. There should be an option on the top bar of your screen. And if you click on that, you can either type out your message or at the end of Stuart's presentation today, we'll have some time to open up for questions. So you can either ask your questions at the end, or if something comes up along the way, just feel free to type that up in the chat. After this video is finished, the recording will be available on our YouTube page, and I'll be sure to make sure that we mention it on our LinkedIn page. So if you're not following us on LinkedIn already, be sure that you join us on LinkedIn, and you can find out when the videos have been posted to our YouTube channel. I'll add some links into the chat here so then everybody knows exactly where to head to. So I'll add the links for our LinkedIn and for our YouTube channel.
Thanks, Whitney. That's great. Yeah, just to say to everybody, it's useful doing these presentations. We are in the middle of the holiday season here, so that's why we've taped them so we can use them post this event. Anyway, today's topic for Stoppac is splash zones or wet steel, to be more accurate. So we're looking at submerged steel, wet and atmospheric pipelines, as well as structures. So I'm going to run through each of the applications and the challenges faced by the asset owners, and also how at Stoppac, the Preserve, we can help overcome these difficulties. Okay, Whitney, next one. So just a recap for anybody online who's relatively new to Stoppac. It's a visco-elastic corrosion protection system. And it's a permanent system. Basically, once it's on the pipe, it stays on the pipe or on the structure. The reason it works so well is it remains in its fluid state. It remains a liquid. Surface prep, as I mentioned earlier in the week, is ST2. Just to remove the worst, wire brush, scrape, scour pad, whatever. So it eliminates the need for grip blasting and the need for it to create a surface profile. Stoppac performs better on a smoother profile, as the adhesion is a chemical rather than needing a profile to adhere. So the operational limitations of Stoppac, minus 45 to 120 degrees. No VOCs, which our clients are really pushing towards just now, and very little, if no, waste generation at all. It can be what's left is a cardboard roll in the backing strip. Because it remains liquid, as I've said before, it's unlimited shelf life, which is great, good for us and also good for the clients. And maintenance intervals, if applied by a certified applicator, is 30+ years, and we'll guarantee that period. Extended application window due to the tolerance to the environmentals that Stoppac offers. So that's just a general sort of overview of Stoppac. So moving on, Whitney. Okay, why the splash zone is prone to corrosion? Well, we'll look at the if we look at the different areas in what we called in wet application, there's the sort of 4 main areas for us. We looked at that in a little bit more detail today. In atmospheric space, which is the space above the splash zone, the corrosion rate varies at a height above sea level. So at roughly 30 meters high, the rate is 0.4 millimeters a year. And this increases to 0.7 as you get closer to sea level for obvious reasons, due to the salt deposits entrained in the air and the sea sprays as well. So you're getting a concentration of chlorides onto the metal, which accelerates the corrosion. So the splash zone, so many customers, so many clients and companies with assets in the sea or in rivers, in the marine environment. The highest area for corrosion and the difficult area or the hardest area to treat is the splash zone. So as we look here, we can see that it's up to almost 1 millimeter, 0.95 millimeters a year. And it's just sheerly due to the high levels of oxygen and chlorine in that splash zone. Depends what part of the world you're in, but in general, that's what you'll be looking at. Okay, Whitney, next one. Where we've got a marine application, the splash zone can then sort of be broken down to what we call the tidal zone. So this is high tide, low tide areas. So sometimes it's submerged, other times it's not. And again, quite an alarmingly high corrosion rate per annum, 0.65 to 0.35. But again, these three areas we've spoken about before, perfectly treatable using Stoppac. Same applies, minimum surface preparation. And we can apply the product by rope access if required, just for the ease of application. You can imagine trying to do these applications using traditional coatings and traditional inspection routines. So every time you are at the steel, whether it's for surface prep, inspection, it's very, very difficult to get there and do what you've got to do. So this is a practical solution for an age-old problem. Finally, that ties into the picture on the left-hand side is the submerged zone. This is where the steel is permanently below the waterline, so basically seabed to the waterline above. And again, the rate of corrosion is based by the rate of diffusion of oxygens through the water, and that's accelerated by any marine growth present on the metal surfaces. So these are the areas we're going to just touch on today. Next one. So how can it possibly be that a product can adhere to a steel surface that is completely surrounded and submerged or is wet? Again, it's all in the patent, it's all in the design of the structure of what we call Stoppac wrapping band, WSH. It's a patent solution. So first and foremost, when you're applying the WSH below the waterline or in a condensed environment, the water's displaced as it's tensioned and put onto the steel. As you would expect, there will be residual water, but within the wrapping band itself, there is an ability for the residual water to be absorbed into the wrapping band, meaning you've got true adhesion, full adhesion with the steel and the WSH. And you can see that in the graphic down below. So it's gone from the surface of the steel back into the body of the coating itself. Okay, Whitney. Typical application for us would be in offshore structures, jetties, where we've got the three zones we spoke about, which is submerged, splash, and atmospheric, and of course tidal, where we're in a sea environment. This can either be a complete repair, as we often do in jetty piles. This can be done from the top using rope access, and obviously dive team below the waterline, which is fairly common. Or we can do it again with the dive team, but using a small boat just to apply the product with up to the underside of the jetty, if access allows. It doesn't necessarily have to be completely submerged. We spoke about earlier on the condensed pipelines, wet pipelines. Pipelines that are almost impractical or impossible to dry to get say a standard Stoppac CZ coating on, which needs a dry environment. So WSH is used both on condensed lines and on wet lines. Outer wrap we use HSPX with an overlap of 50%. Again, this just ensures that the steel remains protected and the ingress of water can't happen. Okay, Whitney, thanks. Next one. So what does the industry, not just oil and gas, but all industries, what do they face? What's the problems that they've got and what alternatives do they have? It's a very difficult job to take piece of structure or a piece of pipework that is continually submerged or continually wet, and create an environment where it can be dried for coating to go on. So I would say that the majority of clients and industries are looking for a system that complies with the environment as it is, will apply and can be applied to the wet steel. Normally, these areas are hard to reach. They're complex, they're irregular. Visibility is often not very good. So again, it's got to be something that is helping the applicator. So once it's applied, he knows he's not got, or she knows she's not to go back to the application for some time. One thing that we come back to, not just with this particular topic, is the environmental impact of coating and surface preparation. With Stoppac, still the same applies in the splashstone and subsea. We want to get the worst of the loose and flaking off. That can be done again. We can capture that even subsea, and in the splashstones, just making sure we are not dropping any material or residual coatings, corrosion back to the sea level. The beauty of Stoppac being a wrap means that you are getting the consistency of application quality, so you don't have to worry about wet film thicknesses, dry film thicknesses, or missing patches. If you've got full access to the structure, then you know the product's going to be wrapped or contained within the Stoppac. For these wet applications, the client is faced with very high mobilization and demobilization costs due to the amount of plant equipment they would normally need if they were using traditional methods. In certain industries, we still come across clients who are specifying almost factory type coatings like epoxy systems, TAR, as a maintenance system in the splash zone. This is particularly common in the renewables industry. Now, it could well be that it's just ignorance in regard to have they really looked at how effective that coating is going to be, how quickly it's going to break down through just natural corrosion, but also through erosion as well, with wave movements, vessels coming alongside, and just general debris. So I think it's really important for us to educate the different sectors as to why Stoppac is, it's not even an alternative, it's the correct specification for these wet applications. And again, like all other, and it's in red down the bottom here, we can do this work without shutting the asset or part of the asset down. It's business as usual everywhere else, apart from the work site where we're working in. Whitney, okay, if we just move on. Touched on before, jetty piles. If there's any wet application that is almost continuous, is the need for jetty piles. I was recently down at a dockside in Fife recently. I was a shipyard, and the yard was full of painters, blasters, people applying coatings at the jetty. But what they were standing on, and when you look down below, was a heavily corroded, heavily marine growth on the steel structure supporting the concrete deck. Now, out of sight, out of mind, perhaps, but we have this product, we have this capability of arresting corrosion for 30 plus years, even longer, again, if it's applied by a qualified and certified applicator. Simple 3-coat system here with the WSH, the intermediate coat, then the outer wrap. And this will ensure full adhesion to the wet substrate below. Okay, Whitney, thanks. Another picture here showing actually what life's really like underneath the sea here for application. You still need, as I mentioned earlier, that full 360 access for your surface prep, and you can see the WSH. I think that possibly could be the WSH predecessor, which was the Stoppac CL going on to the pipe or jetty pile there. We see the intermediate coating going on with the diver on the right-hand side. Again, just to provide that extra layer of protection and keeping the Stoppac under tension below the water. Nice, smooth, uniform layer there. Again, no risks of holidays or gaps. Get your overlaps done correctly and the product's there to stay. As I said, it provides a uniform layer. Moving on, Whitney. In a lot of cases, our clients, we would recommend that we use impregnated glass, an outer glass wrap that will take the impacts. Going back to the renewables industry, I would say it's really important that the areas in the splash zone and where the vessels dock to allow the crew to come off, as the crew is only going out there on a daily basis, so they've got to be dropped off on the asset on the wind turbine and then picked up. So the most of the wind turbines globally are used what they call CTVs, or crew transfer vessels, that come alongside, thrust onto the landing zone, and then allows the crew to step off, hook on, and then climb up to the structure to carry out repairs. Unfortunately, you've got a lot of risk there because the vessel itself will damage through impact the existing steel coating, and then to cap it off, it'll then have the friction from the rubber fender on the front of the boat rubbing up and down the factory applied coating. We've seen examples of 6 months later, we're right down to bare steel in a marine environment. So we're starting to see cumulative metal loss within 6 months on an asset that's designed to last for 25 to 40 years. So mistake by the specifiers. This could all be sorted out at factory, but now they've got a complicated and scratching their head on what do we do to stop this. Next one, please. This is it's not a new technology we're talking about here. It's not just come off the blocks. WSH, or CL as it was, has been on go for 10, 15 years. We've got an example here of 10 years in service. Going back then, it was high pressure water jetting to the surface to take it to an ST2, maybe an ST3, and removal of existing coating by induction heating in the dry area. Colin, I thought you were going to say something there.
No.
Okay. And again, in this case, we've discussed the specifications. So it's WSH wrapping band, polyolefin outer wrap. Again, as I said, for additional tension, and then a resin impregnated fiberglass wrap for mechanical protection and UV stability. UV stability both above and below the waterline. Application crew, only 2 people required for this. Again, if we were doing this in any other system, there would be more crew involved, but just the 2. That's application crew. Obviously, there are other people involved on the vessel, and if it's rope access, there'll be other crew and rope access looking after the application crew below. Okay. So this was a client who thought it was a good idea, great idea. If it works, great. But fair enough, wanted us just to prove that once the Stoppac is on, it's doing what it says it's going to do. So what we did here was there were tests, checks every 5 to 10 centimeters, cut out of the coating, right back down to steel, below the waterline, splash zone, and in the atmospherics. And we can say, hand on heart, that after 10 years in service, adhesion was still as good as the day it was put on, and there was no further corrosion underneath the coating. Always begs the question, this for people specifying Stoppac or using Stoppac, there is no need for inspection. When we first were getting involved with Stoppac, our biggest hurdle to cross was always with the inspection teams in different industries, because inspection is always part of the coating, the traditional coating process. It's surface prep inspection, primer inspection, top coat inspection, then periodic inspections thereafter using NDT or UT. NDT and UT are not really possible with Stoppac. It can be done. There are new techniques, but for accurate metal thickness readings to pinpoint, you really do need to cut the Stoppac back to expose the steel below. I believe that that's weakening your coating system. By doing that, you're then creating an area of weakness. You breach the homogeneous layer that you've created using the different coats and the overlaps. So the repair can be done. It can be done successfully, and it will hold. But the whole fact is convincing the client, take away the inspection aspect of it. We are guaranteeing the product for 30 years if applied properly. Okay, Whitney, carry on. For those, I apologise, that have seen this in the first two webinars we've had, and also in previous webinars, but I think the greatest thing that makes Stoppac stand out above coatings and above other alternative coatings is the positive impact that it has on the environment and the positive impact it has on our clients achieving their environmental goals. The classic, of course, is a blast and paint scenario on 100 square meters of steelwork. We're looking at almost 2.5 tons of waste, primarily in garnet, but also in probably contaminated paints coming up. Could be red lead, could be a number of hazardous products that need to be gathered, contained, and disposed of properly. With Stoppac, I go back to the fact it's just the backing strip and the cardboard rolls that need to be collected and disposed of relatively simply. Carbon emissions, well, I mentioned the other day there that our industry or our surface prep coatings industry is responsible for 27% of greenhouse gases globally. Of course, that includes the manufacture of new steel to replace corroded steel, and we can do something about that. And when you're working for corporations with large amounts of assets or large assets, such as a refinery, a manufacturing plant, an oil platform, for example, we can really start to make an impact, and the goals and objectives of that company can be met. One thing to think about as well with a coating, and believe it or not everybody does think of this, we talk about lifetime. And we don't just mean the time between the coating going on until it needs to be repaired. We're talking about how much is it going to cost to maintain this coating for the expected life of the asset, and in today's world, beyond the expected life of the asset. So yes, Stoppac as a material on its own may be more expensive than traditional coatings, but because of reduced preparations and the amount of time it stays on the steel, then it's significantly more economical than traditional methods of protecting steel. Okay. Again, for those that didn't see this earlier in the week, there's your kit. That's what you need. You've got your Stoppac cut to size for this particular application. Your rolls of Stoppac there. Could be anything from 50 millimeters up to 300 millimeters. And your rope access people or your applicators can actually just take the roll to the work site, or they can pre-cut the strips, is often the case. Colin and I just watched a really good short video clip yesterday on field joints in a pipeline vessel. And it was really interesting to see how efficient Stoppac was at these field joints. How quickly the guys got the surface prep done the shrink, put the geotextile cloth on, and then the rock shield the pipe was then extended out and dropped into the sea, into the trench in the seabed, and on they went. Each joint was taking around about 7 minutes to do, and a real good solution for anything that's going into the sea, into a trench. Just, yeah, didn't summary. So for the operators, no VOCs, it was talked about. No hazardous chemicals. No noise, dust or vibration, which is great. We've covered all the environmental points. Again, going back to the fact, it's not just the waste reduction, but it's a reduction in things like PPE, filters, masks, gloves, empty paint buckets. We know ourselves when we're emptying the garage how difficult it is to take paint tins away and get rid of them properly. Multiply that by 1,000 times, and then you're talking about asset owners scratching their heads on how much it's going to cost to remove paint tins, contaminated equipment, etc. For the actual project itself, we provide a lot of cost savings because there's no need for scaffolding and tarpaulins, not in every case, but in a lot of cases. Well suited to rope access, almost built for rope access. We can apply to hot pipes, we can apply to cold pipes. We have the added benefit as well of thermal reduction and noise reduction of the product. Again, tests have been carried out to specify that and put some numbers against how effective it is in these areas. We avoid the risk of dust going into rotating equipment, which is often caused in the blasting, or even worse, dust carrying down into populated areas or other industries nearby. And really that's it in a nutshell. For those that are here, that paint versus Stoppac, especially in the arduous applications such as splash zone and subsea, it really is a no-brainer. And if you are in charge of assets, then give it a serious consideration. If you're in charge of Stoppac area, well, hopefully this has just been a wee refresher for you, and you can take some of the thoughts back to the clients and get them to look at how and why they should be using Stoppac. Whitney? That's me. It's coming up to 1:30. Any questions from the attendees today? No problem at all. If anyone wants to drop me a line or anything with any questions or clarifications, copies of the presentation will be available. So we'll get these to you. And that's it from me. Whitney, do you want to say anything else?
I don't have anything else, but as Stuart mentioned, don't forget to head to our LinkedIn page so you'll be able to know when we've posted this to YouTube, or you can add us on YouTube as a follower and be notified automatically. So check out our LinkedIn or YouTube page and you'll see when this video has been posted.
Perfect. Okay, thanks once again, everybody. And one last webinar to go tomorrow, which is really just a summary of everything from this week. And that's fine. Hopefully see you tomorrow. Bye-bye.